So hello everybody, my name is Aditi and today's workshop is on data manipulation and visualization. So we're going to be going through like a shared, so we'll be posting the collab link, so you'll have access to the workshop and you can follow with us. So this workshop covers a general machine learning pipeline of like how everything works in the general approach and where you can get data sets from, and the focus will be on four specific popular libraries in machine learning data science: NumPy, Pandas, Matplotlib, and
Just one quick thing, sorry, Aditi, if you could slow down a bit. I know that it'll probably be very, very challenging for Julie otherwise.
Okay, sounds good. So the most popular libraries: NumPy, Pandas, Matplotlib, and Seaborn, and other useful libraries, as well as some additional resources that we'll go through together, and an assignment at the end that you can work through. So this is the general machine learning pipeline. There's definitely different variations of it, but I'll quickly do a rundown of what each step really means and what we'll be focusing on for this specific workshop. So the first step is data collection. With machine learning, you're using data to create models. These models are trained on this data, so it's really important, whether it be labeled data for supervised learning or unlabeled data for unsupervised learning. And you can either build your own data sets or use provided data sets based on what the context is that you're working on the project for, and also find public ones. We'll go through that a little bit more. The next step is data preparation. So this raw data is not useful for machine learning and for the model. You need to do some things to it, and like this kind of includes two parts. So there's the exploratory data analysis, also called EDA, where you're looking for patterns, looking for insights, using analysis tools to kind of get more information on the data, what you can interpret from the data, or pretty much really anything that what you need to work with the data. You kind of figured that out through the EDA process. The second part of data preparation is the data pre-processing, which is where data needs to be prepared. So like normalized or errors and biases need to be removed, or null values need to be removed before it can be taken to the model that you are using for the project. The third step is choosing a model. We discussed a few models already, but these models are like, they have a specific, like each model has specific characteristics you need to match with the problem that you're dealing with. And you would also need to kind of figure out what type of exploration needs to be done on the data, what type of preparation needs to be done on the data based on the model, as well as how accurate it is, and like biases and stuff that exist. The commonly used models include linear regression, logistic regression. There's decision trees, as well as k-means. There was a workshop last week on that, and just there's a bunch more: neural networks, deep learning, all those models you get to choose. And then the next part is training the model. The objective of the training step is to incrementally improve the performance of the model using like these cycles of like updating model parameters and like updating the weights and the biases of the model based on what the model learns from the training data that you provided. And then comes to evaluation. So this step is basically testing your model on a controlled data set that the model hasn't seen before, and it kind of tells you, like, it's somewhat of a representation of what the model will look like for the real world. But it's at that point that you will have that opportunity to see what changes you can make to the model, how you can improve the overall process of your training and building your project. And then comes to parameter tuning. It's a trial and error sort of process where you change the model's hyperparameters, so to improve the model performance. But if you recall, like from last week, we discussed a little bit about hyperparameters versus parameters. So hyperparameters are things that you change, stuff like, let's say, like the number of times the model looks at your data set, or the learning rate at which the model is improved. So different things like that, those are the hyperparameters, whereas each model itself also has these model parameters or values that are for how the model will perform, and what values it would use when doing calculations and different things like that. So that's the model parameters, and hyperparameters are what you do tune using the parameter tuning method.
Sorry. Are you also moving your slide? Because we still see the same page.
No, I'm not moving the slides at this point.
All right. And can you please go with slow?
Okay. So the next part is prediction. The prediction process is where you take data that the model has never seen before, and that the data is really as close to the real life data that your model will be working on, and you try to see how your model will perform on that. So these are in general the machine learning process and the machine learning pipeline of how your data moves through each of these processes and how your project will surface at the end. Okay. So the focus of this notebook and our workshop today will be on data collection as well as data preparation, more specifically data visualization and like the EDA process, the exploratory data analysis process. And the first part, well, I'll talk a little bit about where you can find public data sets. So there's definitely a lot of websites out there. There's Kaggle. Some of you might already know about Kaggle, but there's definitely a lot of data sets that you can find on there. Then there's Amazon data sets. Each of these lists of data sets has their own characteristics and own unique features. You can go through them and see how they exactly are useful for you and any projects that you are building. And there's like Google and Microsoft have their own data set engines going where they are uploading these public data sets for everybody to use. And there's a really cool repository called Awesome Public Data Sets Collection on GitHub. That would be super cool to check out and see what data sets are available. And a source that isn't often used is probably government data sets. So Canada itself has like a bunch of data sets like the government has put out there for people to use and see how they can apply machine learning and data science on it. Okay, so this is just an example of one of the Government of Canada's websites. So for this notebook specifically, we'll be going through a specific data set throughout the entire time. It's called the Life Expectancy Data Set from World Health Organization. It's found on Kaggle. So you would all need to you need to download the data set, and it comes in a zip folder. Unzip it and upload to your Google Drive, your My Drive folder. Just click on New, and you can upload. Give me 1 second here. Yeah, file upload and upload the CSV file. It's called life expectancy .csv, something along those lines of life expectancy.csv. Okay, the next part that I'll be discussing is data preparation. So this part, as I discussed before, it's for connecting it to your model. So the first part, you have your raw data set, and what you will do is you will go through this iterative process between exploratory data analysis and data pre-processing to get your data ready for the model that you're using. So the focus we are going to be looking at is exploratory data analysis for this workshop, and data pre-processing. You'll get a chance to do that within your own projects and have that opportunity there. And there's lots of libraries available for this. So there's like specific libraries for data mining. So there's something called Scrappy and Beautiful Soup that is specifically for mining data from websites, structured data on using HTML and the specific format that they have. So you can create, get an entire data set by scraping data from websites. And then there's other data processing and modeling libraries. And we're specifically going to be discussing NumPy, Pandas, and NumPy and Pandas for this part, as well as there's like, you can do it data processing and modeling on Scikit-learn, Keras, PyTorch. They all have their specific libraries that you can look at using their documentations, and they have been linked onto this as well, so you can have a look. And for data visualization, we'll specifically focus on Matplotlib and Seaborn, but there are still other ones that you can check out. Okay, now I'll hand it over to Shreyas for getting us started with the libraries.
Okay, awesome. Thank you, Aditi. I'll just share my screen. Are you able to see my screen?
Yes, we can.
Yep.
Okay.
Yes.
Thank you. Thank you. Yeah. So yeah, that was really a a brief introduction to, how we get started in machine learning. So now let's get started on how we would, get started on any project in machine learning. So first of all, as Aditi mentioned, there are various sites to get your data from, such as Kaggle or Google Dataset Search Engine or Microsoft Search Engine or anything. But once you have the data set, what you need to do is, first of all, you need to import the data set so that you can start working with it. So for that, I think we have 3 ways to do it. So the first one being, we can directly upload it on runtime on Google Colab. So for that, what we need to usually do is on the left pan here, you can see a few symbols. So you just need to click on the file symbols and then click on this upload to session storage, and then navigate to your own file where you can find, like, wherever you have the data set on your local computer, and just open it. So that way you can upload a data set here, but the only disadvantage of this thing is as soon as the session stops. So essentially you can see here that your session is still running. So as soon as this disconnects, it would disappear. And if you start the session again, you won't find this file here. So for that, what we have some other methods for, so for now, I'll just delete this thing because we don't need it here. So to overcome this disadvantage, what we have is we have 2 other methods to do it. So the other method is to upload your data set on GitHub repository and then call it from there. So for that, what you can do is, first of all, go to GitHub, create a repository under the project name and upload your data set there. And then maybe after that, you can click on data set in your repository and then click on view raw. So as soon as you click on view raw, you would see a link to the raw data set. You just need to copy that link and store it as a string variable called URL in Colab as shown below. So I've given you a piece of code here. So you just need to store it under a variable named URL here so that you can access it further. So the last step is—
Shreyas, can you zoom in a little bit? Some
yes,
students, even though they're young eyes and got their dose of carotene, is still tiny.
Yeah.
Thank you.
Is it better now?
Yes, it's better. If it's still not, please write in the chat. Thank you.
Okay. Yeah, so this is the code that you would need. So you can paste your copied GitHub link here as instructed here. So for this, you can either go through again, you can do a random Google search and you can get a lot of articles wherein they'll tell you how to do it. But I've also mentioned the process here, so might as well go through it again if you don't understand it. It's very easy. And after that, after you have copied it, the URL here, now you have to call the dataset so that you can start processing it in the Colab notebook. So what we do usually is we would cover this further in this session, that you need to use pandas to read that file. So for this code, I'll just mention it as we go along. So that's the second way to do it. And the third way is to mount it on Google Drive and then import it in Google Colab. So as Aditi mentioned, you have to first download it from Kaggle and then upload it to your own drive. And after uploading it to your own drive, what you need to do is, I'll show you right now. I'll show you a demo of how to do it. So once you've uploaded your your file or the dataset file to Google Drive, what you need to do is come here, select a code here, and then paste this whole code in one of the code tabs here. And after this is done, you need to just run it. As soon as you run it, you would see this thing. So as soon as you see this link, you just need to click this link. You just need to go and give access to your Google account. Just allow it. And as soon as you did this, you would receive this window wherein there would be an access code. So just need to copy this access code, go back here, and you need to paste this in the authorization code box here. After doing this, just press enter. And as soon as you do it, it takes some time to load it. And as soon as it will be done, it would say mounted at content drive. So right now, your data set is mounted on your drive and you've imported it to your Google Colab. So for that, again, just to remind you, you need to download this life expectancy CSV file dataset from Kaggle, and the link is here if you cannot find it directly, or otherwise just go to Kaggle and just write in life expectancy dataset WHO and you would find it. So, okay, that's how you mount it. Now, now you need to initially install all the libraries, but like since Google Colab is like a platform which is updated regularly, so you didn't. So this is some step that you can basically skip here. But just for just so you know, I'll just tell you what you usually need to do. So for any library, if you need to install any library, you just need to type this pip install command followed by the library name here, and the Google Colab will instantly install the said library. So right now, as NumPy, Pandas, and Matplotlib are very general libraries, it is already stored or already installed on Google Colab notebooks. So you don't need to do that. But if you need to do it for any other libraries, this is something you should keep in mind. So after you've done installing that, what you need to do is import those libraries. So basically, for you to function with those libraries, you need to import it first in your workspace. So how we do that is you need to just write import as a keyword followed by the name of the library, such as like for NumPy, it would be import NumPy as NP here. For Pandas, it would be import Pandas as PD. For Seaborn is SNS. So basically, this is the library name followed by the initials that you would need to that you would use to access it every time you call it. So basically, every time you can't go in there and write p pandas dot something. So for the ease of that, we can just declare basically short version of it and import it as in the following method, like import pandas as PD. So every time you need to call pandas, you just need to write PD dot whatever the command would be. So that is this thing, importing thing. Now I've included the links here for doing the same thing in your Python or Conda environment. So if you have something, or if you have Jupyter notebooks installed on your local computers under Anaconda or under Python, so you can just click on any of these links and follow the steps on how to install it on your local computers in the Conda environment or the Python environment. So after that being done, that being said, now we need to load the dataset in our notebook, to explore it further. So for that, what you need to do is you need to assign a variable. For in this case, we have assigned df, and df is basically the variable that is most widely used because of the ease, just data frame. So you can import it as df is equal to pd.readcsv. So basically, as we go down further, I'll also come to this point. We have included documentations of every library. So every library has some set of this commands that you can use to do stuff in the notebook. So this is readcsv. Readcsv is a command which basically reads your data set from the particular maybe web link, or maybe if you upload it in the Google runtime here, just the dataset name or something. Yeah. So this is something that you need to do in order to import it into the Google Colab notebook, and just to explore it further. So after doing that, let's jump to first NumPy section. So NumPy in general is a fundamental package for scientific computing in Python. So as you might know, there are some vectors or arrays, some vectors or matrices in real life. So in order to process that in Python, we use the NumPy library. So basically, it is a Python library that provides multi-dimensional array objects and various derived objects such as masked arrays and matrices and much more. So if you need to explore this further, I have included the NumPy documentation. So basically, I'll just show you a demo of how to just navigate through a documentation. So as soon as you open it here, this is different for every library. So for this library, what is NumPy installation quick start? You can also find the tutorials here on how to use the library and all the other information. So basically, whatever you need, you can just navigate to the same page. So for instance, if I need to install NumPy, I can just navigate to installing section on the particular website, and it will show me all the details of how I can do it and for all the options that I have. So for Miniconda for Windows or Mac users, for Miniconda for Anaconda, or for Linux, everything. So in this way, you can navigate all the libraries. all the libraries documentation. Now coming to why should we use NumPy? So in Python, we have lists that serve the purpose of arrays, but they are really slow to process. So NumPy, what NumPy does is it overcomes that barrier, and it aims to provide an array object that is up to 50 times faster than the traditional Python list in terms of processing speeds and in general. So the array object in NumPy is called ND array. So it's something that is a terminology in NumPy. So the array is called ND array, and it provides a lot of supporting functions that make working with ND array very easy. Arrays are very frequently used in data science, as you would discover, and as some of you might already know. And speed and resources are something which need to be optimized from time to time in the field of data sciences. And through that point of view, NumPy is really a very useful tool and a very basic tool to learn when you start your journey in the world of Python and world of data science. So how to do it again? Just to summarize, if you don't have it installed, just write the command pip install NumPy, and it would install the NumPy. Then the next step would be importing it so as to use it further in our notebook. So for that, just import NumPy as some abbreviation. You can change this accordingly, but this is like something standard that we always use in the field of data science. So NumPy, importing NumPy as NP is something that we usually do. So after that, let's jump on to the functionalities in NumPy, what you can do actually with the NumPy. So for the first thing that you can do is create arrays, like as in create matrices in Python. So as I said before, NumPy is used to work with arrays, and the array object in NumPy is called ND array. The simplest way to create it is by using the array function. Now, in the previous workshop, as Pravish also mentioned it, there are a few functions which are user defined and few functions which are under library. So basically NumPy is a library, and array function is something which is already present inside that library, and we can always call that function and use it in our analysis. So for that, I have some demo here. So basically what you do is just assign again a random variable name, call numpy np.array, and define your array. So in that case, in this case, for demonstration purposes, I've defined array as 1, 2, 3, 4, 5. It's just a simple array to showcase to show how, like, what kind of array and how is it, what type of array is it. I've given this functions of print. I've given this commands of print array and print the type of array. So as soon as we run it, as soon as we run it, it shows me what my array is and what the class or type of my array is. So in this case, as I mentioned earlier, it's ND array, which means it's just a simple array in NumPy. Now moving on to the dimensions in array. So as you might know, even with matrices, even in mathematics, you have 0D or zero-dimensional arrays, one-dimensional arrays, two-dimensional arrays, three-dimensional arrays, and so on, like multi-dimensional array. So a dimension is the number of indices or subscripts that you need in order to specify an individual element of the array. So if you want to explore more, or if you want to refresh your concepts of what a dimension of an array is, you can click this link here and read on further. So for 0D arrays, it's essentially just one element. So dimension is basically something which something on the lines of rows and columns. So for 0D, it doesn't make sense to have any rows and columns. So it's just one element. That's why it's called zero-dimensional dimension, so that it does not have any elements. So basically, essentially, they are the scalars. So each value in an array itself is a zero-dimensional array. So I've just defined it, or I've just included this for your demonstration purposes. So this is a zero-dimensional array. The same way, one-dimensional array is something which is just it is just unidimensional or unidirectional. So this is something again for your demonstration purposes. The 2D arrays are arrays that has 1D arrays as its element, and they're used to represent the second order tensors. So basically, this is what it is. And as I mentioned, like two-dimensional arrays have like rows and columns as their dimensions. So this is 2D arrays. The similar way, 3D arrays has 2D arrays or matrices as its elements, and they represent the third order tensor. So in that, in addition to the rows and columns, we have a third dimension called the another element. So this is, another dimension. So this is first dimension, this is the second dimension. And rows and columns are, in itself 2 dimensions. So that makes it 3-dimensional. So 3-dimensional array. Moving on further, checking the number of dimensions of an array. So basically we have a keyword for that. It's called NDIM, so n dimensions. So what you can do is you can check any dimension of an array by writing the name of the array dot NDIM. So that would give you how many number of dimension of an array we have. Moving on further, we have a higher dimensional array. So if you want to define any higher dimensional of arrays, you can do that by using NDMIN keyword, or define or including it in the np.array as an argument, np.array function as an argument. So once you do that, and if you print that same array, now it would show that your array has a dimension of 5. So basically, this number can change depending on your needs, how many dimensions you need to include. So just so to avoid confusion, I have defined array in every step of I've defined arrays in every code snippet here, because I don't have anything to work with. So that's why I've defined them. But in your case, you might have something already loaded in the dataset or already from the dataset that you can work on. So this part, the definition part is just for demonstration purposes, but you can actually use all these functions and all these arguments wherever or however you want to. So
I'll just jump in a second because we have many members that joined in the last few minutes. I just want to give a reminder. S'il y en a qui veulent écouter la session en français, il y a l'option en bas de la page interprétation en français, donc n'hésitez pas à l'utiliser. So for those who just joined, want to use the French version, don't hesitate to do so. Thank you.
Thank you. So moving on further, accessing the elements in an array. So how we can do that is, there's something called indexing. So as you might already have been made aware in the last few workshops, that in terms of coding, every time you count something, you count the indices, it always starts from 0. So the counting always starts from 0, 1, 2, 3, 4. So in that way, if you want to access any particular element in an array, you can do that by referring to its index number. So for instance, just to give an example, if this is my array, it has 4 elements, 1, 2, 3, 4, and I want to access the 0th element or the first element or the or in terms of indices, the 0 position. So if I do that in this, the 0 position is 1. So as rightly mentioned, like if we say 0 indices, the element would be 1. Again, similarly, to get the second element, you need to give the index as 1, because again, remember the index number starts from 0. Again, to get the third and fourth elements, you need to mention it as index number 2 or 3. And in this case, it's just a demonstration purpose that add the third and fourth elements from the following array. So basically, the third element from this array would be 0, 1, 0, 1, 2. So this 3, and the fourth element would be 4. And addition would give you 7. Similar way, in 2D arrays, you would have 2 dimensions again to access. So just for demonstration purposes, if you want to access the second element on first dimension, so basically, as I mentioned earlier, this would be considered as 1 dimension, and this would be considered as another dimension. So if you want to access the second element on the first dimension, so first dimension is this, and second element would be index 1. So basically, how you define that is, you first define which dimension you want. So we want the first dimension, that means 0 index dimension, and then the second element. So second element would be index number 1, because again, remember the counting starts from 0. So you can access the second element on first dimension in this way. Again, if you want to access the fifth element on second dimension, again, the same drill. The second dimension is at index 1. So I've given the index as 1, and it's the fifth element. So I'll give the index as 4. So that's how you access the fifth element, and so on and so forth in 3D arrays. In negative indexing, if you want to do, if you want to access the last element from the second dimension, you can do it, both the ways. So instead of starting from 0, you can start from the back end. So basically what you need to do is, again, if you want to access the last element from second dimension, so this is your second dimension, which has the index of 1, and the last element would be indexed as -1. So always remember that if you want to access any array from, the last, moving backwards, it always starts in negative. So it would be denoted as -1. The first element would be denoted as -1. So that's how you access or access an array from the end. The next thing that we can do with NumPy is slicing the arrays. So if you want to break down the arrays into one or like more parts, you can do that. It's called slicing. So there are many ways to do it. I'll just cover some few ways of doing it here. So basically, this is again for demonstration purposes. Slice elements from index 1 to index 5 from the following array. So this is our array, and you need to slice elements from index 1 to index 5. So how you do that is, again, type 1 to 5. So what it would do is, it would not consider the last one. So basically, it would consider everything between index 1 to index 5. So that being said, it would be 0, 1, 2, 3, 4, 5, 6. So we need to access from 1 to 5. So 0, 1. So that means it would access from 2, 2, 3, 4, 5. So it would access these 4 elements. Similarly, so on and so forth. If you need to access everything from, a particular index to the end of the array, you just define it like this. So for instance, in this example, it's from 4 to end of the array. So you define it in this way. Similarly, you can read up on this. I've included everything here, just so for the time. So keeping in mind the time constant thing, I might need to skip this. So you can just go through it and get back to me with any questions if you have. Next would be finding the shape of an array. So how we do that is, there's again a command called .shape. So it would be again the name of the array .shape. So it would give you the shape of the array. So in this case, since it's a 2D array, I get a shape in terms of rows and columns. So for this array, the shape is 2 and 4. So basically, this is like 2 rows and 4 columns. So this is the shape of an array. Similarly, you can do for every other shape. So for every other thing. Again, coming to reshaping an array. So if you want to change the shape of an array, as in you want to change the number of rows and number of columns, again, that could be done with the command called reshape. So again, it would go as array name .reshape and whatever size you want to do it. So basically, if you want, like in this case, I want to reshape my array in the size of 4 to 3. I mean, I want 4 columns and 3 rows, as opposed to whatever earlier it was. So we can do it in this way using the reshape command here. Again, the same thing with 3-dimensional array. You can go through this. Now, flattening the array is something which means converting a multi-dimensional array into one-day array. So for this, what we usually do is, there's a fixed command of reshape -1. So what it does is it just brings any dimensional of array into one-dimensional array. So if you want to learn more about flattening, you can just go through the hyperlink that I've provided here. Similarly, next thing is iterating an array. So if you want to, just iterate through the elements in array, you can do that by using for loops. So for example, I've shown you an example here of how to iterate through one-day array. So for that, I've mentioned a for loop here, and yeah, you can just look over it, and it's kind of self-explanatory. The next thing is joining arrays. So I'll just briefly go over this. So basically, if you have 2 arrays and if you want to join them, there's a command called concatenate in NumPy again. So what it usually does is it just joins the 2 arrays together. So if it's like just concatenate, then it would just simply join it together without having any without doing any deductions on its own side. So if that means some values would be repeated in that, it would do so. It would not eliminate those. So basically, again, there is another function called stack function through which you can again join the arrays. So basically, how you can do is you can join it horizontally as well as you can join it vertically. You would find the explanation here and the examples here. It's pretty much simple and it's self-explanatory. So that was NumPy section. Now again, just to emphasize, this was really a general introduction, and the use and application of NumPy libraries as well as the pandas library differ from project to project or analysis to analysis. So it's up to you on what functions or what particular functionalities in those particular libraries that you want to use. Now moving on to pandas, as I told you, pandas is something you need to access. You need in order to access the data sets and do some.
Sorry, Shreyas, just
Yeah.
sorry to interrupt. Just wondering if we should take the questions now, or do you want to take them at the end?
Yeah, I'm thinking of taking them at the end, because after this there will be a brief portion by Aditi, and then maybe we can move on to Q&A.
Sure, makes sense.
Okay, thank you. So basically, pandas is a Python library which is used for working with datasets. It has functions for analyzing, cleaning, exploring, and manipulating data, as you could see further. Pandas allows us to analyze big data and make conclusions based on statistical theories. And it can also clean messy data sets and make them readable and relevant. So more on pandas information can be found here in the pandas documentation. You can just go through it. And let's see how we load the data frame. So basically, as I mentioned at the very beginning, you can do this by this command called pd.readcsv, and then the source from wherever you are extracting your data set. So in this case, we have done it on Google Drive. So I've given the link to the Google Drive here. That's how you do, or that's how you read the data set and import it as a data frame. So if you want to know what is actually the data frame, you can read up this article that I've linked here. So these are some basic functionalities that we can do in order to get started, in order to explore our data. So this is dataset.head that gives you the first, head means initially every row from the top. So basically, I've mentioned here 15 rows. So that means first 15, it will display me the first 15 rows. So this displays the first 15 rows of the data set. In order to access the last 5 or the last data sets, last rows of your data set, you can use the command called df.tail. So tail means it would display you basically all the rows from behind, like those whatever is at the end of the data set. So this is the same thing again. If you want to know what is in general information about your data set, you can do that by using the info function. Basically, if you write df.info, because we have imported our data set under the name df, so df.info gives you all the data type, all the basically description of your data set. So it includes data set, data type, what is the non-null count, that means how many non-null or non-zero values are there in that particular columns, and what are the basic data types. Describes does the same thing, but it gives you the statistical methods or the statistical quantities of the data set. So that means you will get a mean, standard, minimum, maximum, 25% 25% of the interquartile range, 50%, 75%, and the maximum value. So it would display according to every column that you have. Similarly, again, df.shape would give you the overall shape of the data frame, how long, like how many rows and how many columns are there in the data frame. So always read it as rows and columns. So we have 2938 rows and 22 columns in our data set. dtypes again does the same thing. It tells you the data type of each column in the particular data set. Index gives you what index of the range of the index indices in the data frame. df.column gives you the names of all the columns that would be there, what would be there in your data set. And if you want to access the number of counts or number of values in each. So for instance, in this particular column called years, we have different years, and we have different number of values under each year. So if you want to get a count of how many values are there in particular for that particular year, you always use value count. So that's how you get, how many values are there under that particular year. In this case, it's year. In this case, in other case, it is status. So status, we have two kinds of status in our data set, developing and developed, and it gives you how many countries or how many values are there under the developing and under the developed status. Now, to sort values, so what we can basically do using sort values is we can sort values by a specific column. So for representative purposes, we have done this here according to the life expectancy column. So if you do df.sort values by life expectancy, it would basically give you all the sorted values for the particular column, in this case, life expectancy. So this is a very general functionality of histogram. So if you know, in statistics, it's usually considered that, if you have the bell curve, your data is normally distributed. So this is something you can check. This is very basic histogram that you can functionality that you can do in Pandas, but you can do the same in Matplotlib as well as all the other data visualization libraries. So we've just done this here in order to give you a histogram of all the features or all the columns that are under this data set. You can go through this. Now coming to data selection, if you need to select anything specific column, you can do that by following this syntax. The data frame name followed by the name of the column and whatever things that you need. So in this case, we have requested for the first few values of that particular column in the data set. You can do the same by accessing more than one column at the same time and doing again the functionality that you want. In this case, we have requested it. We requested the last few values of that particular column. Now, if you need to get access to specific rows and columns, you can do that by referring to the index or the indexes of the particular rows and columns that you want. So if you want to get rows through 15 to 20, the syntax would look something like ilog. The syntax would look something like this. Now there is a distinguishing factor here. ilog is something that is used when you want to specify a list or range of indices, and loc or the location is used when you want to specify a list or range of labels, as in the the column name. So in this case, if I want to just access the rows, I would just give the index number of the rows that I want to access, and I'll get the particular number of rows. If you want the same way, if you want particular number of rows as well as particular number of columns, you can do this same thing. You can say number of rows followed with differentiated by a comma followed by a number of columns. Then if you want to as mentioned earlier, if you want to access according to specific locations, you can do that by again specifying the indices as well as the labels of the particular column that you want. This is again the same thing. These are just the different iterations so that you understand or you get gist of how to use ilog and log. So you can go through this. And yeah, I think that is it for my section. I'll hand it over again to Aditi for continuing with the next section.
Okay. So the next part of the workshop is on the pandas part for subsets of the data frame. So right here we are choosing, we were choosing a subset of the data frame. So we have the data frame here, and we are choosing where the data frame's country is Canada. So right now this displays all the rows that have Canada as the country. So that's like choosing a specific subset of the data set that you want based on some conditions that you choose. As well as for this example, life expectancy, we wanted any country, any rows that have it under 50. So we can see that these are all the rows with that life expectancy. And so one way of joining different subsets of the data frame would be using the pipe character, or you can kind of think of it as like an OR character. So we're looking for countries, rows that have countries as Canada or as countries for United States of America. So it lists all Canada's rows as well as United States of America rows. And then there is another character called just ampersand or and. This one takes it as, so like right now it takes in Canada as a subset and where the life expectancy is greater than 80. So you can see from this is using the describe method, you can see that it chose 11 rows, whereas before it had 16 rows or something for Canada's rows. It just depends on the life expectancy wherever it was greater than 80. Now, you can also store it in another data frame. You can store whatever subset of the data frame you choose in a data frame called DF 2015. So that's like the latest data available. So these are all the data frames that would include the five, for the head, you're getting the first 5 rows. Now, the next part we want to briefly discuss would be pandas null values. So there is a method of figuring out how many null values each of these columns has. So if you do df.isNull and then you sum it, you can figure out how many null values there are in each column. So you can see like the hepatitis B, there's a lot of missing values there, as well as for population. But for year status, it's all there, as well as country, they're all there. So there's this goes into a little bit of data pre-processing, but you can fill these null values with specific value using fill NA, or you can drop them completely just based on what you are required by the data, and you can analyze that based on your project. So right now, if I drop right now, this approach would be dropping all the null values. So any null value there are in any of the rows, it will drop that row. So if I describe that data frame, it shows that at first it was like around 3,000 rows. Now it's cut down to 1,600 something. So it reduces the data by quite a lot. So if you're looking for that, that's fine. Or else you can fill it in with different values. And I've listed a source that you can look into more detail on that. Now, if any of you is familiar with SQL, it's basically a language or library. Well, not a Python library, but a language for working with and analyzing databases. And a lot of those SQL functions operations can be performed in pandas as well. You can find more information in this link, but I'll briefly go through 3 of them. So one of them, it will briefly go through 3 examples. So this one is grouping by country, and then you're trying to figure out the size of it. So like each one, if you group it by country, for Afghanistan, there's 16 different rows that correspond to each of the years, the data for each of the years, and then it's the same for other countries. And you can also group by status and then see how much of each value there is. So like for developed, there's 512 rows of data. For developing is 2,000 something rows of data. And then this example here does it by, it merges 2 data frames together, which is common in SQL, that is commonly done. So these are just 3 examples of how SQL and a lot of the functionality from SQL can translate over to pandas. Okay, so that's the general pandas overview. There's lots of different things that you can do, and you can look through the documentation, lots of tutorials online. The third library we'll be going through is Matplotlib. Again, this is a library that you can do a crazy amount of stuff with this, and there's definitely a lot of documentation out there. There's definitely a lot of documentation out there for it, but we'll go through a few examples. So over here, I chose country as Canada, and I plotted the line plot for it based on the year as well as the life expectancy in the Y column, and year on the x-axis. So you can see like Canada's life expectancy grew in the 2006, and then it dropped, but it's growing at the moment. Well, it's 2015. And then what I did was I changed it. I added more parameters within these methods and functions and changed it. So over here I added added changing the color of the line to green, so it's like a really green line, as well as changing the line width to 10, so it's like a really thick line there, as well as adding a title onto there, so life expectancy, and changing the font size of the title to 20, or changing the color to, like, let's say pink, then once you run it, it'll be pink. So it's definitely a lot of functionality out there. The documentation has that, and so you will be able to look through that. So I'll show you a quick example of, let's say I don't want to view this. I don't want to view this graph here. I want to save it on my laptop or save it on Google. So what I'll do is like look online, because this is the Matplotlib documentation. I can search up save figure, and one of these results pops up. And once I control find, I can find something along the lines of save. And okay, where is this? Yeah, so save figure comes up here and it shows me, okay, this is how you would use it. So you have the general function name, as well as all the parameters that goes in, an explanation of each of the parameters, as well as sometimes the easiest way is just looking on Google, save figure matplotlib, and you can look through Stack Overflow. It's always really helpful to see what other people had problems with and how you can solve them. And this has a similar approach where someone asked a question relating to saving figures, and someone answered it. So I'll show you what that looks like on here. So once you save that figure over here, you will be able to see it. This would be it saves it within the files on Google Colab, or you can save it on your Google Drive. So it has it over here. You can download it, and this would be the figure that you see. Okay, so the next example that I would like to show is this circle plot that shows the status of countries. And the approach that I took for this one was I gave it the data frame and choosing the status, and then giving it a specific pie plot that I want, and then setting these percent signs for the percentage. But a different way of plotting, a similar way, would be to input it as the data frame itself and the value counts. So there's what I'm basically trying to get for this is that there's different ways of approaching the same plotting of visualization. So it's definitely up to you. You kind of get that feel of, this is the way that I want to do it, and this is the way I like to do it. So this kind of plots out in a for loop. It plots out all the relationship between all the parameters, columns, and life expectancy. So you can look through what the relationship is, and we'll discuss that a little bit more later on. You can look through that. So this example is more of a subplot sort of example, where you're plotting 4 different plots. So I did it by life expectancy by country. So in Canada, United States, India, China. So seeing like the relationship between each of these countries. So Canada's life expectancy grew in the middle, and then like it went down and it's growing, but America and China and India all are pretty much growing throughout that same period. So you can take a look at those relationships, as well as so the approach that I took for plotting this was I defined 2 by 2 subplots, and so that would be 4 subplots, and I can use the specific axes to specify what I want to plot and where. But another approach of just plotting 2 might be adding these subplots. Like you can add a subplot and specify the row, column, and information. It's all in the documentation. Just go through that. You would be able to figure it out there. So you can set it up in different ways. Like these 2 examples show, so you can set it up in different ways, and feel free to experiment what you like and what makes sense to you, or versus what doesn't. So this is just a brief overview of Matplotlib. The next visualization library is Seaborn. It's based on Matplotlib, but it has like a simpler interface, and the Matplotlib was more of a low-level sort of approach to plotting these visualizations. But Seaborn is like it has a high-level interface and quite easily and simply understandable, and it creates really visually appealing graphs and stuff. Information can be visualized easily. So an example that we show here is like a heat map that shows this is, if you look on the y-axis, these are all the rows in our data frame, and on the the x-axis is all the columns. So this visualizes what values are null. So like you can see in country and year, none of the values are null, but in life expectancy, there's like a few values in the middle, and like hepatitis B, as I mentioned before, there's a lot of missing values. So you can see that visually over here and see, like, show it in your report or whatever you want to create for your project. So this was just an example of taking specific columns and showing those. Okay, so this one is a pair plot between all the columns and between each of the columns. So you can see like this shows the relationship that each column has with each other. And I'll show you another example of how the exact values there will be, but this is just a simple pair plot you can plot to see how the relationship between different factors. So this is a scatter plot between. So using this Seaborn library, you can just call it as a scatter plot and put down your X value. So I want schooling as my X value, Y value as life expectancy. And I want to choose my data set that I created for 2015 specifically. And the relationship you see here is like as the number of years of schooling increases, life expectancy also increased for most countries. And this other example shows adult mortality. So as expected, if there's higher adult mortality, there will be a lower life expectancy. And in a similar way, if there's a higher value for HIV and AIDS, life expectancy decreases. So I think you can see those correlations a little bit there. So these relationship plots really show what you can plot different columns for different to show different characteristics and analyze the data set. So I put down I want a scatter plot and I want the X to be adult mortality and the Y-axis to be life expectancy, as well as I want this color feature for stating what's the status of the country. So if it's developed, it was more on this corner of the plot where there was higher life expectancy and lower adult mortality. And you can see that pattern, like it's an expected pattern, and just you can verify that, or for data sets that you don't know what patterns exist, you can see through these plots. And similar way, developed for schooling, same thing, and as well. So this one was more of just an example of showing there's more ways you can add more information to your plot. So I added the year over here. It doesn't give a specific analysis through it, but it's a way of like you can, if it's developed and undeveloped, you can change the color as well as like these symbols for specific information you want to show. And similar approach, taking any of these plots and trying to figure out patterns through them. This code basically goes through plotting two together. So you can see like I plotted the developed countries here and then the developing countries here and looking at their adult mortality rate. So you can see patterns through that. And the last thing on Seaborn, a really cool thing you could do is plot this correlation matrix. So you see life expectancy here. This life expectancy has a really negative correlation with this feature here. If we look down what feature it exactly is, it is adult mortality, which is what we saw on our graphs as well. And then in other cases, it has a positive correlation to something like 0.75 over here. It has a positive correlation with schooling. So those are two things that we saw, and we can confirm it with our correlation matrix. So that kind of gives like an introduction to all of these four libraries that are really popular. These are all the official documentations. So please free to take a look. And also you can search on Google or their documentations, or Stack Overflow is a really great library, really great website to get more information right away. And then, so the last part I'd like to mention is the assignment. So you can answer like there's questions posted on the Kaggle life expectancy data set right over here. If you open this up, it has a bunch of questions. So try going through those based on these libraries that we have shown, and try to answer these questions. So like, what impact of immunization coverage on, what does immunization have on life expectancy? And you can also learn to explore the Titanic data set. There's also lots of tutorials on the Titanic data set specifically. It's a pretty popular data set. I would just list all the passengers and their chance of survival on being on the Titanic. Yeah, and one last quick thing that I want to show everybody is if you're a student at a university or some college or some sort of educational institution, you can get this GitHub student developer pack through your university or educational institution email, and you will have the chance to go through some of these course free classes sort of thing, where you can go through, you have these for 1 year or whatever, depending on something like Data Camp is really useful for data science and gives you a 3-month individual subscription. So that's something that you can check out. Just wanted to point that out. Not a lot of people know about it, but it's a pretty cool resource to check out. Yeah, now we can open up the floor for any questions.
Okay. Awesome. Thanks, Aditi. I would just go ahead and take a few questions from the beginning. So don't worry. And if I miss out, feel free to unmute yourself and ask it. So the first question was, can you have a list of multiple numbers in an array of dimension 0? Answer is no. It was again, I think I see the comment again. The next one was the same question. What is the point of 0D array? It's just one object. Yeah, it is true. It is just one object. I just kept it there for the representational purposes so that, we start from the basics. Where can we find the Python notebooks? We have already shared the link with you. Please feel free to go through chat. It has been shared at least 2 or 3 times now. How do I do for notebooks and for other sessions? So you would be getting the notebook links for each session separately. So just keep a look in the chat and you can get the link respectively. Can you write array 1 4? Simon, yeah, you can write that as long as you know what the position of it is. Don't interchange it to 4 and 1 and then say, why I'm not getting the output. So as long as you keep the position or the sequence as it is, you can write it. There are different ways of syntax and you can always look it up. So a bit confused with the negative index logic, array 1 minus 1. I would assume that 1 would refer to row and minus 1 to column. So Emily, for that negative index logic, it depends on what you are accessing. So for my particular example, what I meant by array of 1 and minus 1 is I want to access the second element, or since it was a 2D array, I wanted to access the second dimension. That's why the 1 index comes there. And minus 1 would be the last element of that particular dimension. So that's why it was 1 minus 1. But if you say 1 minus 1 would refer to row and column, I don't think that could hold true in that case. It's just the indexing, and doesn't mean that. Does Python automatically know what it's reading? Like in Java, do you specify to read integer or a string when scanning a file? Does it do this automatically here, or should I convert numerical string to actual numbers? Also, how do I know when reading a CSV, the difference between values and attributes the values are for? So Aditi, if you can answer the first question, maybe I can go to the second one of how does it know when it's reading a CSV? So basically CSV stands for comma separated values. So it's kind of an Excel file. So basically which has the separated, columns and everything. So the CSV format itself is self-explanatory for, the Python or Pandas library to know that, this is separated from this. So all the values are separated. So as long as your CSV file is fine, it can interpret and it can read distinct or different values in the particular column or row. Aditi?
Yeah, I think in general with Python, there's lots of libraries out there, which are basically people have written these functions using just pure Python to give us more functionality where pretty much anything. So the libraries that we've shown have their own syntax in terms of calling methods or calling functions, and you can just use the documentation to figure out the syntax there, but it reads it based on the syntax or based on what the syntax for the library.
Okay. Awesome. The next question was, how does SQL or Pandas compare to PySpark? So I would say SQL and Pandas are comparable. PySpark and Pandas are comparable. So basically, what usually I would say is SQL. It's a different language in itself, and it's very useful initially for for storage and just calling the data set from the database. So SQL has its own importance. If you say that being said, coming to Pandas and PySpark, it both has almost same functionality, I would say, but they differ in some aspects. Like for example, if you ask me, operations in PySpark data frame are lazy in nature, like they take much time, but in case of Pandas, we'll get the result as soon as we apply any operation. Similarly, in PySpark data frame, we can't change the data frame because apparently PySpark data frame has an immutable property, meaning that you cannot change anything. But in Pandas, this is not the case. We can do anything with the data frame. Also, complex operations in Pandas are easier to perform than in the PySpark data frame. So in general, SQL and Pandas are comparable, and Pandas and PySpark is comparable.